Sorry, I don't have my thing up yet. Today we're going to be doing 5-1, comparing and ordering fractions. And we've probably already talked a little bit about fractions, but I'm not sure if I'm going to do that first in class or if I'm going to do this in class first. So we'll just see kind of where we are. So 5-1, comparing and ordering fractions. So first of all, we need to know what multiples are. Okay, multiples, when you think of multiples, okay, I totally have the wrong thing on. Think multiply. Okay, when before we divided, but now when we do multiplies, when you do factors you divide, when you do multiples you multiply. Okay, it's in the name. Okay, and when you think about it, it's the product of that number and any other non-zero number. Okay, and so for example, let's just do 3. Okay, so the multiples of 3 go on forever. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15, 18, and you could go on and on and on. Okay, when you do factors, there's a finite number. Okay, there's only a certain number. Multiples go on for infinity. So if we have 3 and then let's say we had 6. So 6, 12, 18, 24, 30, 36, and on and on and on. Okay, so those would be the multiples of 3, multiples of 6. Okay. Now when we get to the least common multiple, it's exactly what it sounds like. Okay, so before we were doing the greatest common factor, well, we can't find the greatest common multiple. We'd go on forever. So we find the least common multiple. Okay, so the smallest, if you want to think, smallest common multiple. Okay, so between 3 and 6, we just look up here, what numbers do they have in common? They have 6, they have 12, they have 18, and they would have some more if we kept going. They'd have 30, and they'd have 36, and they'd have 24, they'd have all these. Okay, but what is the least? The smallest common multiple is 6. The first thing you want to do when you're finding a least common multiple between two numbers is to look at the bigger number. If the smaller number can go into the bigger number, that's going to be your least common multiple. Okay? This should be kind of a review, so I'm going to go somewhat quickly. So that's the old way to find least common multiple, which you can still do. But another way, if you have numbers that are really big or numbers that don't have very many multiples in common, like 12 and 40, okay, then you can use prime factorization. It's a little different than we did before, though. So if we do 3 and 4, 2 and 2, so it's 2 times 2 times 2 times, I'm sorry, I just put too many 2's there. Let me erase it real quick. Whoop. Isn't that cool? I can just erase right there. Okay. So it's just 2 times 2 times 3, okay? And 40, let's do 4 and 10, 2 and 2, 2 and 5. So this one is 2. I'm going to line them up again like we did before. You do not have to on this one as much, okay? So what you're going to do on this is you're actually going to circle the greatest the greatest power of each factor, because these are kind of factors, of each number. So when we look at this, we have 2 2's here and 3 2's here. So we're going to circle the one that has the most. Okay? Before, when we find the greatest common factor, you circled what they had in common. You're not doing that anymore. You're going through each number that's down here, and you're circling the ones that have the most. So this one, there's the most 2's down here. This one has 1 3, So you have to circle every number that they have. And then 1, 5. And then you multiply them all together. So 2 times 2 times 2 times 3 times 5. Whoopsie. See if I can get that back. Sorry. There we go. That's pretty close. Okay. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 5 is what? 120? Is that correct? That's what I have on my notes. So it's 120. So this seems like a lot of work, but that I don't think is nearly enough work as much work as doing 12, 24, going all the way through these multiples. But whichever way, unless it tells you, if it tells you have to use prime factorization, then you need to practice this. Okay, so it just kind of depends. So over here, again, you can do we'll just practice prime factorization again since that's what it's telling us to use. So 2 and 3, and then a times a. And over here, it would be 9 times 2, 3 and 3. So it'd be 2 times 3 times 3 times a times a times a. So again, we're going to pick, there's some 2's in here. There's just 1, 2, so you just pick one of them. This one has 1, 3. This one has 2, 3. So we're going to pick the one with the 2. This one has 2 A's. This one has 3 A's. So 2 times 3 times 3. And then a cubed. So this would be 3 times 3 is 9. So it's going to be 18a cubed. And hopefully you can just look at 6 and 18 and know, hey, I know 6 goes into 18. Again, my smaller number goes into my bigger number, so I know my bigger number is going to be my least common multiple. Okay, so this is just finding the least common multiple, however you want to do it. I do not care. Okay, so if we have 6 and 16, okay, well, oh my goodness, I mean, I don't know what goes in, I don't know my multiples of 16 off the top of my head. Okay, so this one might be easier to do the factor tree. Okay, so I'm going to go ahead and do the factor tree. 2 times 3, and this is 4 times 4. And then 2 times 2, 2 times 2. So we have 2, 2, 2, 2, and then from the 6 we have 2 and the 3. So we circle the one with the most. And we have this 3 here. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3, I don't have this answer down, so 16 times 3, 6 and 3 is 18, 48. Okay? And so you could have probably done that using the old method, and that's fine. If it doesn't tell you, you can do it however you want. I do not care. Okay? So what about 15 and 12? Okay, so again, you could do your multiples. I would start with your multiples of your big number, but I'm going to go ahead, because I feel like you've done that before, and do it the factor tree way. So 2 times 2 times 3 times x. And here we have 3 times 5. So just 3 times 5 times x times y. So again, we circle the ones with the most. There's 1x and 1y. So this is going to be 2 times 2 times 3 times 5, and then xy. So those are circled. So 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. So 60xy. And again, I do not mind if it doesn't tell you. If you just want to do your multiples up here, 15, 30, 45, 60, on and on and on. And then you could do 12, 24, 36, going on until you find one. I don't mind if you do that, but the bigger the numbers, or the harder it is to find it. So sometimes it's easier to do it this way. Again, if it doesn't tell you, I don't care how you do it. Okay? So now, comparing fractions. So, when we are comparing fractions, sometimes it's going to ask you to graph them. Sometimes it's just going to ask you to compare them by finding the least common denominator and comparing them that way. Okay, so if it asks you to graph them, we have 6/11ths and 9/11ths. So, this is positive, and you have to know that these fractions are between what two numbers? If you're in pre-algebra and you don't know what numbers those are in between, we're in trouble. Between 0 and 1. Okay, I always say, is it bigger than a half or less than a half? We can always label 1/2. Okay, well, is 6/11ths bigger than a half or less than a half? Okay, well, it's less than a half. Okay, I'm sorry, it's bigger than a half. I'm speaking wrong. It's bigger than a half, because half of 11 is 5.5. Okay, 5.5. 6 is bigger than 5.5, so it's bigger than a half barely. And 9/11ths is bigger than a half. So which one is bigger? Well, if we were to count out 11 notches, okay, so if we did 1, 2, 3, 4, 5, 6, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 notches, let's say. Then we, in this half should really be in the 5.5, right about there. Okay, then 6/11ths would be right here. Okay, and then 7, 8, 9/11ths would be right there. And so you just label it. For the most part, the biggest thing I'm concerned about is that you would have the 6/11ths close to a half, but still bigger than a half, and you'd have 9/11ths closer to the 1. It's more of an estimate. This would be fine. Okay, so now we're also doing some negatives as well. Okay, the easiest way I've found to deal with negatives, so these are between 0 and -1. The easiest way I have found to deal with negatives is to think, okay, which one would be bigger if they were positive? Okay, if they were positive, the 2/5 would be bigger. Okay, so that means the 1/5 is actually bigger because it's going to be closer to the 0. So if we want to make 5 notches, 1, 2, 3, 4, 5. Okay, 1, let me change my color here. -1/5 would be right here. And then -2/5 would be right there. Okay? Now, so we need to know that the -1/5 is bigger and the 9/11ths is bigger. Alrighty? So if it just gives you two fractions and says which one's bigger, or compare using greater than, less than, or equal to, then sometimes you have to find the least common multiple, okay? Or the least common denominator, I'm sorry, the LCD, the least common denominator, okay? I know you've done these before, but we're just going to refresh your memory, okay? So if you have 5/8 and you have 7/10, we have to find the least common denominator, which is the same thing as least common multiple, just that they're in the denominator now. So we have 8 and 10. Okay, so we have to go through our multiples. What's our least common multiple? Okay, well, 8 won't go into 10, so it's not that easy. But if you do your multiples of 10, we have 10, 20, nope, it won't go into that. 30 won't go into that. 40, oh, it'll go into 40. 8 will go into 40. So 10 times 4 gives me 40, so 7 times 4 gives me 28. 8 times 5 gives me 40. 5 times 5 gives me 25. So, which one is bigger? My 7/10 is bigger. So we would say 7/10 is greater than 5/8. You have to go back to your original to see which one is bigger this